In Learning Objective A, we're going to use properties of radicals and exponents to simplify expressions. One of the things you want to keep in mind is this. If you have a radical that has two numbers on the inside, for example, if we have the square root of 9 times 16, you can actually pull that apart into two separate ones. You could say the square root of 9 times the square root of 16, which is easy to do, which would end up being 3 times 4, which equals 12. Another thing you can do is if you have a fraction. Let's say we had, using the same numbers, 16 over 9 as a fraction, but it was the square root. You can break that up into the top of it and the bottom. You can do the square root of 16 over the square root of 9, which would equal 4 divided by 3. It's very handy properties. So if we look at some examples to try to simplify, let's look at this, the cubed root. When I look at the cubed root of 3, remember I'm trying to think of some number 3 times that gives me 3. And there isn't a nice whole number. The same as the cubed root of 9. Some number 3 times that gives me 9. I have a square root of 9, but not the cubed root. So what I would try to is maybe reverse the rule and crunch these two together. If you crunch them together, you can write the cubed root of 3 times 9. That's 27, so then I'll do the cube root of 27. Now, do I know the cube root of 27? Is there a number 3 times that gets me 27? There is. A 3 would work, so the answer here is 3. Now, if we look at letter B, they want us to find, for this bottom part, the fourth root of 3. So some number 4 times it gives me 3. It's not going to be a whole number answer. This one, the fourth root of 48, a number 4 times that gives me 48. I'm tempted to try 4, but that would give me 64, so that doesn't work. 3 only gives me 27, so that doesn't work. However, we can crunch these together under one radical symbol, do the fourth root of 48 divided by 3. 48 divided by 3 is 16. Now, is there such number that you take the fourth root and get 16? What number 4 times is 16? It would actually be 2. So there is a nice answer for this one. It's the answer 2. Now this one here is a little bit more involved. Is there a cube root that gets you 40? There is not one number that if you multiply it 3 times that will get you 40. But there is one that's embedded inside of 40. I can pull 40 apart into two different numbers. So two numbers that multiply to 40. One is 8 and another is 5. So that's 40. And then I can pull it apart. So the cube root of 8 times the cube root of 5. One of these I do know. There is a cube root of 8. One number 3 times it gets me 8 is 2. Is there a nice cube root of 5? A number 3 times that gets me 5? There's not, so I'm just going to keep it like that. And that's going to be our final answer. That's considered simplified. Now this is a trickier problem though, because a lot of people at first will try this. They'll say, well, 40 is the same as 4 and 10, which is a great try, but if you try it, here's what you're going to find out. If you break this up, it's still not going to happen. They want the cube root of 4, not the square root of 4. So the cube root of 4, there is not a nice whole number, nor is there for 10. So that's not going to help me. So if I tried that, I would ultimately just scratch it and eliminate it and see if a different pair works. And again, ultimately, the best combination, the only combination, is an 8 and 5 for this case. All right, let's take a look at number 1 here. Again, is there a cube root of 2 or a cube root of 4? If there is, then evaluate it. Unfortunately, there's not. So if I can crunch these together, and I do the cube root of 2 times 4, 2 times 4 is going to give me 8. And is there a cube root of 8? You got it. What number 3 times is 8? The number 2. So it actually does work in this case. And sometimes it may not. You may not be able to simplify it further and you have to stay with this number, but this does go to something nicer. Here, is there a number 5 times that gets me 4 or a number 5 times that gets me 8? There is not, so my only option is to try to crunch them together. So I'm going to multiply 4 times 8, which is 32. And then I'm going to try to evaluate it. Is there a number 5 times such that I get 32 there is a number that works for this, and it'll be 2. Let's look at some more. Here we have the cube root of 54. Is there a number 3 times that gets me 54? 4 is close. 4 times 4 times 4 is 64, but that's not quite going to work. And there isn't a cube number for 2. So I'm going to bring it together, do a cube root of 54 divided by 2. If you divide that, what you're going to get is going to be 27, so the cube root of 27. And we're getting really familiar with that one, so what number 3 times is 27? The answer here is 3. Again, these two numbers here, 81 and 3, neither of them have their own cubed roots, but I can bring them together under the same radical symbol. So I'll do 81 divided by 3. 81 divided by 3 is 27. Well, we just found this one out. The cube root of 27 is 3. So both of these actually have the same answer, even though they look completely different. So let's look at some more specific properties here. Number one, what this is telling us is that if we have two numbers that have the same base, in this case a 3 and a 3 are the same bases, what can you do? Well, just remember back on chapter 6, what if I had 3 squared and 3 cubed? What you did in that case is you actually added the exponents. So you do 2 plus 3, and you'd say it's 3 to the 5th. Well, these work the same way. It just happens to be that the exponents are fractions. They're called rational exponents. As long as I remember what happens when you can visualize the problem, because we can visualize that there's going to be 5 3s here, know that property and apply it. So here, for this first problem, I'm going to say it's 3, keep the same base number. You're going to do 1/2 plus 3/2. Remember, adding fractions, you need a common denominator, and then you add straight across, so it's going to be 3 and 1 is 4. You keep the half there, don't change it to 4. The new exponent, therefore, is 3 squared, and that actually is a nice whole number of 9, which is the answer here. Another property we looked at in chapter 6 is what if the two exponents were right next to each other? For example, if I had 3 to the 4th power and it was all being squared, if you did that, remember you would repeat this twice, so you'd have 3 to the 4th times 3 to the 4th. That's 8 exponents, so you just multiply them. 4 times 2, when they're right next to each other, you're going to get 8. So that applies to this particular problem here. This numerical case, yes, their exponents are fractions, but that's okay. Just do the 2 as the base. We're going to do 3 over 2, and you're going to times it by a 2. You have to remember how to multiply fractions. To multiply them, you can make any number a fraction by just putting it over 1. Remember, on multiplication, you just multiply straight across on the fraction. So we're going to have a 2 is the big number. 3 times 2 is 6. 2 times 1 is 2. This is really 2 cubed, and 2 cubed is the number 8. The next property, this third one here, we've kind of already looked at a little bit. If you have an exponent on the outside and a couple things on the inside, you can just distribute that exponent to everything on the inside. So for this, 9 times 4 all to the 1/2 power, I would just give that 1/2 power to both pieces. So 9 to the 1/2 and 4 to the 1/2. Remember, the 1/2 power just means the square root. The square root of 9 is 3. The square root of 4 is 2. So together this becomes and simplifies down to 6. The fourth rule, remember, we don't like negative exponents. We can put it over 1 and just drop it down, change the exponent to positive. So if you have 16 to the negative 1/2, I'm just going to put it over 1, and I'm going to bring it down. So I have 1 over 16 to the positive 1/2 power. Remember, 1/2 is square root, so the square root of 16 is 4. So the number goes on the bottom, that 4. There's still the 1 on the top, and that is our final answer there. Looking at number 5, don't forget what we did in chapter 6. What if we had x to the 6th power over x squared? What did you do when it looked like division? Well, you have 6 x's on the top, 2 on the bottom. You subtract them. 2 will get crossed out, so we did back then, we did 6 minus 2 was 4. So you subtract the exponents. We're going to do the same thing here. So we're going to take this numerical example, which has a base of 5. You always take the top exponent and you subtract from it the bottom. So we'll do 3/2 minus 1/2 as an exponent. When you subtract, you need a common denominator, which we do have. So I'm just going to write 5 as my base. 3 minus 1 is 2. The little 2 stays there. 2 over 2 is 1. So the answer is 5 to the first power. 5 to the first power is just 5 as our final answer. And then the number 6 is very similar to number 3. If we have an exponent on the outside, but there's a fraction on the inside, everything on the inside of those parentheses gets the fraction, or that exponent. So I'm going to put the 1/3 to everything here, which gives me 8 to the 1/3 over 27 to the 1/3. This just says the cube root of 8. Cube root of 8 is 2. This one says the cube root of 27, which is 3. So this nicely simplifies down to 2/3. Now let's kind of look at different examples and see if you can see which rules to use. Letter A here, remember they are separated with the base of 6. In this case, think about if you multiply or add, you actually add the exponents. So you would do 6, a little 2/3 plus a little 1/3. Common denominator is already there, so it's going to be 6, 3 over 3, which is 6 to the first, which just equals 6. Letter B, the exponents are right next to each other, so I'm just going to multiply. So that's going to be 3, a little 3/4 times a 4. Remember, you can make any whole number a fraction by putting it over 1. When you multiply fractions, just go straight across. So we have 3, 12 over 4. 12 divided by 4 is 3. 3 cubed is 3 times 3 times 3, or 27. Letter C here, we have 2 things on the inside and an exponent on the outside, so I can give that exponent to both pieces. 16 to the 1/2 power times 25 to the 1/2 power. This just means the square root of 16. Well, that's 4. This means the square root of 25, which is 5. So it comes down to 4 times 5, which is going to be 20. Letter D, we have an issue with a negative exponent, so I'm going to actually put it over 1 and drop this thing down. There's going to be a 1 sitting at the top there, and then it's 8 to the 1/3 power. Now I can try to evaluate the cube root of 8. The cube root of 8 is the number 2. Do not put the 2 on the top. It's sitting at the bottom. What's on the top is just the 1, so this is a fraction answer of 1/2. Letter E, it's division, so what I'm going to do is take this exponent and subtract this one from it. So I'm going to write 7, 5/2 minus 1/2. It's already a common denominator, so 5 minus 1 is 4. The 2 just stays there. 4 divided by 2 is 2. 7 squared is 7 times 7, which is 49. The last two here are some extra practice if you want to go through it. Number 5 is a little trickier. The same base number, so it's 9. These are separated, so I'm going to just add the exponents. Now, unfortunately, the exponents do not have a common denominator, so you are going to have to do that. The common number I can make between a 6 and a 3 is a 6. So multiply the 3 by a 2. What I do to the bottom, I do to the top. So the question is, what is 9? 1/6 plus 2/6. Well, that's 9. It's going to be 3 on the top over 6, which is going to be 9 to the 1/2, which means the square root, which is 3. The last one is 81, and we're going to do some subtraction of that numbers that are being divided, so it's going to be 81. It's always the top number minus the bottom one. Common denominator is already there, which is great. 5 minus 3 is 2 over 8. 2 over 8 simplifies to the fraction 1/4. So the question is, what is the 4th root of 81? And that's going to be the number 3. We have 4 more slides related to the simplifying of radicals. This time, we're going to look at letter A here, and we're going to notice it actually is a radical symbol. My suggestion to you is to rewrite that radical symbol as an exponent. That's the square root, and just remember the square root is a 1/2 power. 9 x to the 6th is all in that square root symbol, so I'm going to do that to the 1/2 power. Then you can just apply our properties of exponents, which that 1/2 goes to everything. So it'd be 9 to the 1/2. It'd be x 6 times 1/2. 9 to the 1/2 is the square root of 9, which is 3. 6 times 1/2 is 3, so that's the new little exponent, and that's our final answer. Letter B is already set up to look like a rational exponent. I'm just going to distribute that little exponent to both. So 4 to the 1/2, y to the 6 gets that times a 1/2. Again, the square root of 4 is 2. 6 times 1/2 is 3, and that's going to be our answer. Again, letter C here is written as a radical. I would prefer to see it as an exponent. It's the cubed root. The cubed root just means the 1/3 power. So I'm going to rewrite that whole thing is in the radical, so I'm going to do that to the 1/3 power. The 1/3 power goes to everything in here. So it would be x, a little 3 times 1/3, over y with a little 6 times 1/3. When you multiply, if we want to put them over 1, we can, and just go straight across. So this is going to be x, it's going to be a 3 over 3. This will be a y, a 6 over 2. That does simplify. 3 over 3 is 1, so I'm just going to put x. 6 over 2 is 3, which is that, and that's going to be my final answer. Letter D is a nice combination of chapter 6 and 7. You just want to simplify it so there's one number, one A value, and one C value. So the number 3 looks great because there's only one of those, but I have 2 A's and I have 2 C's. First thing I recommend is to get rid of your negative exponents. So I'm going to bring that up and rewrite it as 3A3 to the 3/2 power C. And then I brought the C up so it becomes C to a positive 2. And then I have an A on the bottom. So I'm going to combine together these two C's, and I'm going to get 3A to the 3/2 C cubed. So my 3 is great and my C is great, but I have 2 A's. So I must take care of that. So I have to subtract that. So I'm going to keep the 3. I'm going to do A 3/2 minus 1, and I'm going to keep the C cubed there. Now, a fraction and a whole number, I can write the 1 as a fraction by putting it over 1. I need a common denominator, so I'm going to times it by 2. So what I'm really doing is going to be 3 minus 2, which is 1, and the A is a 1/2, and it's C cubed. So that'll be our final answer. Looking at a few more, 9 and 10 are great extra review. Again, this is a square root symbol, so I'm going to rewrite the square root symbol as a 1/2 power, and then distribute that 1/2 power to all the pieces. 25 to the 1/2, y to the 4th times 1/2. Square root of 25 is 5. 4 times 1/2 is going to be 2, so we get 5y squared. For number 10, I'm going to write the whole thing as x to the 6th over y squared, all to the 1/2 power. I'm going to distribute the 1/2 power to both. Six times 1/2, again, if you want, you can put it over 1 and just multiply straight across. This will be 6 over 2 on the top, which is 3. So I'm just going to write 3 right away. This bottom one here would be 2 over 2, which is 1, so I'm just going to write it as y and be done. These last two are great practice. They're already written in rational exponents. So number 11, be careful that 1/3 has to go to the v, the u, and the 8. So it'll be 8 to the 1/3, u cubed with a little 1/3, v9 with a little 1/3. The cube root of 8 is 2. For u, I'm just going to do 3 over 1 times 1 over 3, which is 1, or 3 over 3, I'll just put that. For v, it's 9 over 1, so I multiply straight across. I get 9 over 3, and I'll just write that for now. Simplify the final answer. It's going to be 2u v cubed. Number 12 is the last one we're going to do. Again, I can look at this. The 2's look great. There's only one number. There is only one z, but I have an issue because it's negative, and there are 2 x's. So I need to crunch the x's together, and I need to make that z positive. So let's make the z positive first by bringing it up. Gives us 2x z positive 3 over x to the 1/3. Now to crunch the x's together, all I need to do is subtract. This is the first power, so it's going to be x 1 minus 1/3, and that z cubed is still sitting there. To subtract, get a common denominator, so I need to have a 3 there, so I'll do a 3 and a 3. Then I can simplify and get the 2. It's going to be x. The new exponent is 3 minus 1, which is 2. And I keep the 3 there, and then it's z cubed. And that's the final answer.